Let's work through the quiz. First problem is to integrate a product, x to the 5th times natural log. It's sort of hinting at the possibility of integration by parts. And yeah, if you try a substitution, it doesn't really lead anywhere. So try integration by parts. First bit of advice, what should v prime be? It should be something easy to integrate. Therefore, do not choose natural log of x for v prime. Instead, make that u and make v prime the other factor, x to the 5th. U prime will then be 1 over x. V will be 1/6 x to the 6th. So now using the formula, uv minus the integral of v times u prime gives product of these two is 1/6 x to the 6th natural log of x minus the integral of the product of these two things is the integral of 1/6 x to the 5th, because one factor of x cancels. You get 1/6 x to the 6th natural log of x minus 1/36 x to the 6th plus c. And if you're wondering, no, absolute value signs are not necessary here. Why not? Well, for one thing, the original integrand function is only defined when x is positive. So that's the assumption here is x is positive. Therefore, you don't need absolute value signs. If you put them there, it wouldn't hurt. Not wrong, but you don't need them here. Only need them when integrating 1 over x or some modification of that, where x could be positive or negative. Second problem, it's tempting to distribute the sign of x through the parentheses first, and that is okay. But you can use integration by parts with this as it is right away. Letting u be x plus 3, not just x, but all of x plus 3, v prime being sine x. Both of those things are easy to integrate, but if you choose u to be x plus 3, then u prime is simpler, just 1. If v prime is sine x, then v will be negative cos x. So u times v will be negative in parentheses x plus 3 times cos x minus the integral of v times u prime, so minus the integral of negative cosine of x. The two minus signs combine to make a plus sign, giving you negative in parentheses x plus 3 cos x plus sine x plus c. You can also, if you like, at the end, distribute the cosine through and also the minus sign through and write it as negative cos x minus 3 cos x plus sine x plus c. If you did your distributing at the start and then use integration by parts, you probably ended up with your answer in that form. But both of these answers are correct. This one's just straight away, mostly memorized integrals with a little bit of a curveball thrown at you there. And also remember, square root of x is x to the 1/2. 2 plus 1/2 is 5/2. As a fraction, 2.5 as a decimal is fine. Integrating then gives you negative 1/3 e to the negative 3x plus natural log of the absolute value of x. You do need it there because x can be positive or negative there at least. I mean, it can only be positive there. So you could argue this entire function has a domain that's only positive numbers. And therefore, I guess because of that, I won't mark it wrong if you don't in this example. But in general, you want to allow for both positive and negative values there. Then you get x to the 7/2 all over 7/2, which is the same as 2/7 times x to the 7/2. Integral of that is inverse tangent. Don't forget your plus c. Next problem is partial fractions. Write this function as a over x plus b over 5 minus x, the entire function. Solve for a and b. Multiply both sides by the common denominator of x times 5 minus x to get complete cancellation on the left, leaving you with a 1, not a 0, not an x, but a 1. On the right, when you multiply this by x times 5 minus x, the x's cancel. So you're left with a times 5 minus x. With this second fraction, if you multiply times x times 5 minus x, the 5 minus x's cancel, leaving you with b times x. Now plug in your numbers that make this simple to solve, like 5 and 0. If x is 5, the a term goes away, you get 1 equals 5b, and therefore b is 1/5. If x is 0, the b term goes away, and you're left with 1 equals 5a. So a is also 1/5. So you're really integrating 1/5 over x plus 1/5 over 5 minus x. However, you have to be really careful when you integrate that second term. Here, you get a minus sign because of the minus sign in the fraction. If w were 5 minus x, dw would be negative dx. And therefore, you get a minus sign there. You can also double check that with the chain rule. When you differentiate the inside function here, you get an extra factor of -1. I'm imagining many people put a plus sign there. Okay, it's a half a point off on the quiz. On the gateway, it'd be no credit. This kind of problem does show up on the gateway, so I'm trying to prep you. Remember that for the gateway. If you got something minus x down here, you're going to have a minus sign there. Of course, if there's two minus signs, if there's a minus sign there as well, then you'd end up with a plus sign. Two minuses making a plus. In this last one, it's the cosine factor that has the odd power. So factor off one of those and put it next to the dx. That motivates you to say, hey, I want this to be my dw or negative dw, so w better be sine x. So that dw is cos x dx. That's w squared, this is dw, but what about this one? We did an example like this once before. That's cos squared x squared, and therefore it's 1 minus sine squared x squared. And if w is sine x, it's 1 minus w squared. But when you expand that, you have to use FOIL. It's 1 minus w squared times itself. First times first, outside times outside, inside times inside. The last times last, you'll get a middle term that's minus 2w squared. Like that, don't forget that. That gets multiplied by w squared before you integrate. So you're going to integrate w squared minus 2w to the fourth, plus w to the sixth. Get 1/3 w cubed minus 2/5 w to the fifth plus 1/7 w to the seventh plus c. And finally, w is sine x. 1/3 sine cubed x minus 2/5 sine to the fifth x plus 1/7 sine to the seventh x plus c. First gateway is very similar problems to this, though it's got 6 problems instead of 5.